In this video we talk about when architecture analyses should be performed during a project to be truly effective. As you know, Automotive SPICE is not a lifecycle model, so the model itself does not answer this question. That's why it's important to discuss timing. When architecture analyses are performed has a strong impact on their effectiveness. Architecture analyses must be performed early in the project lifecycle. This is what we call front-loading. The goal is to identify issues as soon as possible when changes are still affordable and to minimize reworks later on. Typically, architecture analyses start during the quotation phase, when high-level concepts and solutions are evaluated. At this stage, preliminary analyses are performed to support cost, effort and risk estimation, and to decide which architecture options are feasible and can be offered to the customer. In this phase, typically PowerPoint presentations are prepared and shared with the customer, calculations and simulations are performed, and sometimes even prototypes are built to evaluate the solution. Important decisions are taken even before the project officially starts. But there is an important challenge here. The people involved in the acquisition or quotation phase are often not the same people who later work on the project itself. For this reason, it's essential to provide the project team with clear documentation. This includes a baseline of all produced materials, such as concept presentations, prototype evaluations, early analyses and risk assessments, and, most importantly, an explanation of why certain architectural decisions were made, including known risks and boundary conditions. At project start, this information must flow into the system, software and hardware architectures, ensuring that the architecture documentation is complete, accurate and consistent. In practice, this step is often neglected, and also assessors struggle to find evidence of these early decisions. A second point is that architecture analyses, such as FMEAs or security analyses, must be performed before the architecture is frozen. The purpose of these analyses is to identify risks and weaknesses, in other words, how the system can fail, so that preventive actions and architectural improvements can be introduced. Very often, the outcome of these analyses lead to a rework of the architecture. Now, if the analyses are performed too late, when the architecture is already fixed, changes are no longer possible. In this case, the analysis has almost no value. It becomes a purely formal exercise, and the project shifts from acting proactively to reacting to problems. In that case, the analysis loses its value. It becomes a purely formal exercise, and the project shifts from acting proactively to reacting to problems. In practice, architecture analyses must influence architecture and design decisions, not just document them after that important decisions have already been made. Next, architecture analyses are revisited after requirements are defined or updated, for example, for a new release. At this point, we check whether the architecture is still suitable, feasible and verifiable, and we look again for technical, safety or cybersecurity risks. Not every release requires a full reanalysis, but as an assessor, I expect teams to explicitly evaluate whether a reanalysis is necessary and to document the justification if it is not performed. Finally, architecture analyses must also be performed when the architecture is modified, for example, after a major change request. These analyses may include simulations, dependency checks, and interface reviews to ensure that the architecture remains robust, maintainable, and secure. In short, architecture analyses start in the quotation phase, continue before the architecture is frozen, and are repeated when significant changes occur, keeping project feasible, safe, and on track. If you like this video, subscribe to my channel to learn more about Automotive SPICE. Thanks for watching and arrivederci.